Hey guys, it's Dr. McJunkin. Welcome back to week 4 of virtual learning about probability and statistics. This will probably be our last week talking about probabilities. I'm going to move into a little bit of pre-calculus, like intro to calculus limits and stuff next week for you guys going into AP Calc. We're going to end up this week with a couple different ways to show probabilities. One of the ways we're going to look at is tables, or specifically a two-way table, where we have information along the top of the table and information along the side of a table. So let's look at a real-world example of some data that people collected. So the school board of Waldo, a rural town in the Midwest, is considering building a new high school, primarily funded by local taxes. They decided to interview eligible voters to determine if the school board should build a new high school facility to replace the current high school building. There's only one high school in the town. Every registered voter in Waldo was interviewed. In addition to asking for support for new high school, data on gender and age group were also recorded. The data from these interviews are summarized below. So we have lots of information from the town. We have people's ages, we have how they voted, we have their gender as well. So based on this survey of all this information, do we think the school board should recommend building a new high school? This is what a lot you would do in AP Stats next year if you're going into that, is you have some data and you want to make some conclusions based off of that data. So it's an open-ended question. Do we think that they should build a high school? Well, where I might first look at is how many people voted yes. How many people voted yes? Well, I want to then take all of these and sum them up. So if I want to take all the yes votes and sum them up, I should get 273 total yes votes. Then I might want to compare to the number of no votes. How many people don't want the new high school? So the people in this category over here, how many don't want the new high school? And if I sum those up pretty easily, I get 230 people don't want the high school. So it's pretty close. But if you're a majority rules kind of person, so if you say like, oh, well, the majority has the correct answer, majority rules, then you would say yes. You would think that they would recommend building a high school because there are more people that voted yes than no. But it's pretty close. I think it's about, if you total up the extra people over here, the people that didn't vote, there's 273 yes votes over 515 total votes if you add in those no answer people. And that's about 53% saying yes. So again, it's pretty, actually this is exact. It's pretty close, but about 53% said yes. So you might say, well, majority rules, it's over 50%, so they should build a new high school. Let's look at specific categories though. If I'm picking an eligible voter at random, but then I know that they are 21 years old, I interview them, I pick them, and they say, hey, I'm 21 years old. Do I think that they would want to build a new high school? Well, then I want to know how many 21-year-olds voted yes, and how many 21-year-olds voted no. Because I want to know specifically about this person. He's in the 21-year-old age group. Would he think, or he or she, we don't know, would they think that they would build a new high school? Well, let's focus on just the age group that person's in, 21 years old, 18 to 25. Then I want to sum up these two that voted yes, and I want to sum up these two that voted no. So I can see clearly right away that there's a lot more yes votes than no votes. There's 14 no votes, and there are 61 yes votes if I add those together. And nobody abstained. Nobody said no answer. So those are all the votes I have. So if I go back down here, I've already written it down for us. 61 said yes, 14 said no. So 61 out of the total 75 said yes. That's about 81%. So I think, yeah, they would totally want, these younger people want a new high school because overwhelming majority are saying yes. So this one's pretty clear cut. The last one, maybe yes, maybe no. Yeses were a little bit higher, but this one is pretty clear that I think that they would indicate that they would want a new high school. Lastly, I want you to do the same thing for 55-year-olds. how many 55-year-olds do you think that if I chose someone at random and they were 55 years old, would they want to build a new high school or not? Take a pause here. Do the same thing I did for 21-year-olds for someone who's 55 years old. And I'll go over the answer in just a second. Okay, so hopefully you did that problem here. And I want to look at the 55-year-olds that voted yes and the 55-year-olds that voted no. So if I go up to the top again where my table is, 55, that person's going to be in this age group. So I'd want to be summing the yeses, male and female, for that age group and the no's, male and female, for that age group to summarize or to figure out what's going on here. So there are 66 people that voted yes and 79 people that voted no. A few people abstained. There were 4 people that abstained. So there's 66 over, 149, adding in those people that said no answer, that said yes, and that's about 44% saying yes. So these people, probably not. It is more likely that they said no than yes. So they probably would not want to build a new high school. These older populations do not really want the new high school. Okay, so we had a lot of information here. We had age, sorry, got that out of the screen a little bit. We had age, we had their vote, we had gender. That's 3 different pieces of information that I want, or that I have, and I really want to focus kind of on 2 with a 2-way table because there's a lot of stuff going on here. We didn't talk about gender at all in these votes, and so maybe it might be nice to get rid of the gender, just combine the votes here, assuming that gender maybe doesn't matter on people's votes. So since we had a lot of information that we had to sum up a lot in those last ones, what if we did some of the summations already and got rid of the gender divide, assuming maybe it doesn't have a difference? We might want to look later on the gender differences and see if they do affect their vote or not. But right now we're just going to focus on their votes versus their age. So this is going to be a 2-way table because we've got one piece of information along the top, their vote, and we've got one piece of information along the side, their age. Last time we had 3 things, so it wasn't a 2-way table. I'm going to call this a 2-way table because I've got 2 different things I'm looking at, their age and their vote. So what I need to do for this 2-way table is take the information from the last example. Well, I don't know if I can get on the same screen. I want to take the information from the last example and add them up here. So if I want the people that voted yes that were 18 to 25 years old, I want to add together the 18 to 25-year-olds that said yes. So I want to add the male and female together. I'm combining the genders now and just how many people in that age group voted yes. So 29 plus 32, that should give me 61. And I'm going to continue adding the no votes. So the no votes are going to be the people here, the 8 and the 6 that voted no in that age group. So there should be 14 there. No answer. Nobody didn't answer in that age group. And then what's different about this table too is I've got a total along the right-hand side and along the bottom. So I want to total up all the 18 to 25-year-olds that I have, and that's 75. I'm going to continue, and you should follow along on your notes as well, to make sure that you get the same thing. I'm going to add up the people that voted yes that were 26 to 40 years old. That's 113. 84 of them said no. 6 didn't say anything. They had no answer. And if I sum all these 3 together, there are 203 total people that are at 25 or 26 to 40 years old. For 41 to 65, I should get 66, 79, 4, and a total of 149. And then for 66 years and older, 33 said yes, 53 said no, 2 didn't answer, 88 total. I'm going to total all the way down here too to figure out how many total yes votes did I have. That's 273. So these totals on the side and the bottom tell me the total of each thing. So Along this row, there are 75 of these 18 to 25-year-olds, and along this column, there are 273 total yes votes. It's going to help me out to find some probabilities in a second. There are 230 total no votes. There are 12 total no answer votes. What goes in this bottom right-hand corner is the sum of all these total people and all the total votes, which should be the same. And they add up to 515 total people in this survey that they did. Okay, with this, we can find a lot of great probabilities. So what's the probability that a randomly selected person is in this age group? So I'm randomly selecting someone from all of the samples. So there's 515 total people I could choose from. But I just want to choose the 18 to 25-year-old people. And I can find that right here. The total 18 to 25-year-old people, there's 75 of them. So I can leave it like that, or if I want to turn it into a decimal, it's about 1.146 if I round. Round to 3 decimals always here. So 0.146, or about 14.6% of the, there's a 14.6% chance that I would pick an 18 to 25-year-old if I was just randomly choosing someone. What's the probability that a randomly selected person voted no? So again, I'm choosing from all the people, but I want to know how many, what's the probability they voted no? So the total number of people, I'm still choosing from all 515, but now I want the total number of no votes. But that's nice because I have this right here already, 230. I don't have to do all the sums because I do the sum once, and then I'm done. I just refer back to my table. 230 no votes out of 515 total. That's 0.447, or about 44.7%. So again, more people voted yes than no. Here's the last two is where they get a little more confusing and a little more interesting for this table. So if a randomly selected voter is 26 to 40 years old, what's the probability they voted yes? So here's where it gets a little more tricky because I'm not selecting randomly from everyone. I'm selecting from voters, and I know that they end up being 26 to 40 years old. So my new denominator is not the total of everyone, but it's the total of the 26 to 40-year-olds. 26 to 40 year-olds. 26 to 40-year-olds. And then who am I trying to select? Well, out of those 26 to 40-year-olds, how many voted yes? So I want the 26 to 40-year-olds that voted yes. So this is a new probability here. We call this a conditional probability. I'm going to write that off to the side. We call this a conditional probability because I know something about my voter. I know a condition. It's not just a randomly selected voter. It's a randomly selected voter that is 26 to 40 years old. So I know something about them. I have a condition on what's going on here. So let's go back to my table and look for the 26 to 40-year-olds that voted yes. Here's the 26 to 40-year-olds. Here's the ones that voted yes. There's 113. So that 113 is going to become my numerator, the 26 to 40-year-olds that voted yes. Then I want to divide by the total 26 to 40-year-olds. There were 203 of them. So 113 of these 26 to 40-year-olds voted yes. 203 total 26 to 40-year-olds. So if I'm just looking at those 26 to 40-year-olds, I get the probability that it's 113 over 203, or about 0.557. So a majority of the 26 to 40-year-olds, not a huge majority, but the majority voted yes. It's higher than 50%. If a randomly selected voter voted yes, I know something specific about this person. I know they voted yes. What's the probability that they're 66 years old and older? So again, this first piece, the part that I'm boxing, this first condition tells me what my denominator is. If it just says randomly selected voter, it's out of everybody, the 515. But if I know something about these voters, that changes my denominator. So my denominator should be the total yes votes, because I want to just know out of those people that voted yes, how many were of this age group. So my total yes votes and my numerator is going to be the yes votes that are 66 and older. So out of the total yes votes, how many of them are 66 and older? Well, my total yes votes, if I look at my thing here, are 273. So that's going to be my denominator. 273 will be my denominator. And then my numerator is the yes votes that are specifically 66 years old and older, which are just these 33. So I should end up getting 33 over 273, which is about 0.121 or about 12.1%. Not a lot of the older generation voted yes for this school. So if I know that they voted yes, it's pretty unlikely that they're going to be an older voter. It's only a 12% chance that happens. Okay, so again, whenever I see this, I like to box it because I know something specific about my voters, and that changes my denominator instead of being out of every single person. Let's do one more example here. Let's do one more example about students taking different science classes. Oops, let's get down a little bit so we can see better. Okay, so 80 students are studying one science, biology, chemistry, or physics, and this is the information I know. This table isn't fully filled out, but that's okay. These tables have to sum up along the vertical and horizontal axes. So I know that every row and column must sum correctly. So I can do some quick math. It's kind of like a puzzle. I'm so bad at writing. Let's just scrap all of that. It's like a puzzle, which means I love them so much. So it's like a puzzle. I want to figure out what number has to go where. I can start wherever I want to. There's a lot of different stepping off points. I could do 80 minus 47 to figure out what goes here. I could do 33 minus 19 to figure out what goes here. I could do 80 minus 33 minus 21 to figure out what goes here. And let's go ahead and do that. Let's start along the totals here. So 80 minus 33 minus 21 is 26. So 26 people have to be in biology in order for all this sum to happen. Okay. 26 minus 18 means that 8 people have to be here that are males in biology class. I can do 80 minus 47 now to get 33. Again, you can do this in any order you want. 33 minus 19 should give me 14 here. And then I can do 33 minus 19 minus 8 to give me 6 here. 40, then I'll just do the easy one. 21 minus 6 to give me 15. When you fill these tables out, just check that after you're done, everything sums up correctly and gives you the correct totals on the bottom and on the right. Everything should sum up correctly. Cool. So let's go ahead and do some of these examples here. What's the probability that a randomly selected student studies physics? They didn't tell me anything about the student, so I know that I'm choosing out of all 80 people, the total people here. Or I can look it up here, 80 students. So out of those 80 students, how many study physics? Well, that's the total number of physics people. That's 33. It's about 0.413. Okay. What is the probability that a randomly selected male student does not study biology? Ooh, okay. So I know specifically that I am selecting a male student, and I do not want them to study biology. So I always start with the denominator first. If I'm looking at the male students, I want the total number of male students, which is 33. And I want the students that don't study biology. So I want to add the 6 that study chemistry and the 19 that study physics into 25. So I get 25 out of 33, which if I want a decimal is about 0.758 with rounding. So most male students don't study biology. Okay. What is the probability that a randomly selected female student studies chemistry? Again, I'm selecting just from the female students, and I want to know which ones study chemistry. So my denominator is going to be the total female students, which there are 47 of. There are 47 female students. I want the female students that study chemistry. So I look at the female students that study chemistry. There are 15 of them. So 15 females study chemistry out of 47 total females. So about 31.9% of females study chemistry. Last two, what's the probability that a randomly selected chemistry student, so I want to select from the chemistry students, and I want to know that what's their female. These sound similar. Female student studying chemistry, chemistry student that's female. These are not going to be the same probability. I know it's kind of weird, but the order matters of who I'm selecting from. So why I box these things first here is they tell me what my denominator is. So the numerators will be the same, chemistry students that are female, chemistry students that are female. But my denominator is different. I'm saying what's the probability of the female students that study chemistry? What's the probability of the chemistry students that are female? Okay. So if I box this here, that means I need my denominator to be the total number of chemistry students, which if I look up here is 21. There are 21 total chemistry students, and the ones that are female are 15, just like last time, the 15. But because I want to know the probability that a randomly selected chemistry student is female, it changes my denominator and makes my probability much bigger. 71.4% of chemistry students are female. The large majority of chemistry students are female. And then lastly, let's go to the last one. A randomly selected student is not female. I don't know anything about the student, so it's going to be out of the 80 total students. And in this one, we only have two categories for gender, male and female. So if they're not female in this study, they have to be male. So there's 33 of them. So there are 33 non-female students in the survey out of 80 total, which is actually the one that which is actually the same probability as what we saw for B. The probability that a randomly selected student is not female. Cool. Okay, so again, if you need to rewatch the video or pause, your exit ticket today will be based off of questions like this, where you're filling in tables and you're answering probability questions. Be careful to look for these pieces here, the conditional probabilities, that tell you, hey, I know something about the student that I'm looking at, and it's not just going to be the total here. So look for like randomly selected student or randomly selected male student or student that studies chemistry or student that does this. If you know something about that student, it's going to change the denominator of your probability, and it's going to be a conditional probability. If you've got any questions, I'll be online from 9:30 to 11:30 to answer questions really quickly via email. Also, I'll have office hours today from 2:45 to 3:45. So I hope to see you there. If not, I will see you on Friday for our next lesson in probability. Bye, guys. Have a good day.